Hi 8th graders, this is Mrs. Arnold. I am going to be going through section 1 notes with you today, and this is for my class as well as Miss Letta's class. I'm just going to kind of highlight a few things on the slides, and you can take your notes as we go through the slides. And I will also post a link to the slides so you can go back and take any notes that you may not have gotten. We won't be watching any videos together on here, so that would be a time for you to do that as well. What we're going to talk about today is minerals. So more so looking at how do you know if something's a mineral? How do they form? When we talk about a mineral, there has to be 5 things that have to occur in order for it to be considered a mineral. And we're going to talk about each of these in the upcoming slides. If you find something and it doesn't follow one of these categories, so let's say where it says it's inorganic, meaning it has to be not made from something that was once living. So if you find something and it's made from a once living object, it cannot be considered a mineral. When we talk about naturally occurring, we are talking about things that can occur in nature. No help from man. They are not man-made. You cannot make them in a laboratory. There is some controversy with that because there are scientists who have discovered a way to actually create a diamond in a lab. And so they technically would not be considered a mineral, even though a diamond would be. And they are a precious gem worth a lot of money. Minerals are able to be found in nature. When you find a rock, rocks are basically made up of minerals. So we have lots of little different kinds of minerals that are kind of put together and they make a rock. And then what makes up our minerals are the elements, so things from the periodic table. Inorganic. So inorganic means that it has to be non-biological in origin, as in non-living in origin. So things like coal or chalk are not considered a mineral. They actually would be considered a rock because they are from a once living object, or they're biological in origin. Another example here would be that sugar is not a mineral as it forms from the result of a biological process. So sugar comes from a plant, right? Sugar cane, or sugar beets. And so those are all biological or living objects, and so they cannot produce a mineral. Salt, on the other hand, is a mineral because no plants produce it in a pure form. And so you can find it in nature, and then it would be considered inorganic. It has to be a solid, and in order for it to be considered a mineral, you can't find it in a liquid form. It has to be considered, or it has to be a solid piece or object. Again, remember, way back to 6th grade solids are when we have all those little molecules are really close together and there's a lot of them inside of there. If it's not a solid, it cannot be a mineral. And again, these are just pictures of minerals that I posted on here. Definite chemical composition. So what that means is that the elements from the periodic table are put together in a certain way. So they are made up of a certain kind of element from the periodic table, and they can be one element or they can be a combination. So for the example I have on here is sodium chloride. So sodium chloride, or salt as you would call it, is made of sodium and chlorine. And when you put those together, you get sodium chloride. And that's the only thing that you get when you put it together with one sodium and one chloride. And so that's what it means by definite chemical composition. There's a certain combination, or think of it kind of like a recipe that goes together to make that object. Native elements are when they're made of just one element on the periodic table. So silver is actually on the periodic table, and same with sulfur, gold, copper. Sodium chloride is not on the periodic table, but sodium is and chloride is. So if it's made of just the one thing, it's called a native mineral. Again, here are just a few other ones that would be found on the native mineral or on the periodic table. When we ask or talk about having a definite crystal structure or an orderly arrangement of atoms, what that means is that the atoms that make up that object are put together in a certain way and they make it into a crystal. So you'll see a couple pictures coming up here. So like this is quartz, and this is amethyst quartz on the bottom here. But you can see they have like a definite shape, or they have this little point on the top, and you can even see that in these little ones down here. That is a specific chemical composition. They're put together in a specific way. And you can see over here there's lots of different ways that a crystal can form. And that also will determine if you were to find like a rare, like a gem, and you were to cut that gem, this is kind of in the way that they can be cut, depending on how they're put together. So usually it's a repeating pattern, and they have 3 directionals. And so there's lots of different ones, as I said, so like cubic, hexagonal. And so they are orderly arrangement, and that's what gives the crystal its shape. When we talk about the shapes, you don't necessarily need to memorize all of these shapes that are listed up here, but I want you to realize that there are different shapes that make up that crystal structure, and that's what makes it a mineral. It has a definite chemical composition, so certain things from the periodic table make that, and then they're put together in a certain way in order to form the shape that they would become. There's a couple of different ways that minerals can actually form. They can form through crystallization. They also can form through hot watery fluids or through magma or lava. When we talk about crystallization, crystallization is how they are all formed, and they basically are taking a liquid, whether it's a hot water or whether it's lava, and when that liquid starts to solidify, then it forms into a crystal. And this is just a couple of microscopic pictures of that. They can form from hot or cold solutions, and it kind of just depends on where they are on our planet or what is there as well. So they can evaporate from a cool solution. This happens a lot in dry environments. And then what happens is the mineral is left behind. So this would be a solution that has halite in it, salt, a type of salt. And as the water evaporates away, these are evaporation pools, and then this halite is left behind. So this is kind of like a factory, if you would call it that. So cold solutions is when water containing the minerals crystallizes. And hot solution is basically when the hot water flows through cracks and then it leaves behind that mineral. But either way, it's dissolved inside this liquid, and then as it either cools or evaporates away, the crystal is formed. This video, you can go ahead and watch this on your own. This is just a picture of one of these caves that's formed of salt. It's a pretty cool video. I would go back and watch that. This picture is from some caverns, or a cave, I guess, that would be found in Mexico called the Crystal Caverns. It's miles and miles and miles and miles long, and you can see how large these crystals are. And I do have a video of that at the end of this slideshow as well, and you can find YouTube videos on it, as I said, as well. And so what happens here is this is from a watery solution. So this, I think it's gypsum, is dissolved into water, and that water, as it cools or as it's sitting there, it deposits. So kind of like, think of it, if you've ever had on your sink where you have like that white colored kind of mineral chunky film left behind, that is actually a mineral. And that's kind of how this is formed. They actually have pumped all the water out of this cave so that they can go down and explore. And this is a video that talks about it. You can see they have these kind of like hazmat looking suits on. It's actually extremely hot down there, and a human, you wouldn't be able to stay alive or to live and actually do any research down in there. And they actually, even with these suits on, I think they only last about 15 to 20 minutes before they have to get back out of there. And as I said, there are several videos on here that talks about that. I would go back and watch those. I don't need to watch them with you on here. How minerals can form? They can form through magma or lava. So we already talked about how they could form through a liquid, dissolved in a liquid. They can also form from magma or lava. So magma and lava are basically the same thing. It's melted rock that comes from a volcano. Lava's on land, magma's below land. And so what happens is these minerals are dissolved in this lava, and as the lava cools, the minerals start to crystallize and start to form. There is one other way that a mineral can form, and this is called volcanic glass or obsidian. And this cools so quickly that there is no real crystal structure, and we would call this a mineraloid. And so it is still part of the mineral family, but it's not fully a mineral. There's no crystal structure on it. And remember, it has to have a crystal structure in order to be considered a mineral. Most minerals are formed out of 8 elements from the periodic table. And the 2 most common of those are oxygen and silicon. Those are the 2 most abundant things on our planet, and that means that those are the most abundant elements to make up these minerals. Now, most minerals have oxygen, silicon, and then something else in them, and that's what gives them their different color or their different shape, like the pictures that are down below. These are all silicate minerals in this picture. Silicates are ones that are formed from oxygen and silicon. Now, if they were all just oxygen and silicon, they would all look the same. That means that we have other elements that are mixed in any combination. It could be 2 more, 1 more, 10 more, that make up that specific mineral. I just got a couple of kind of cool mineral pictures on here talking about some of the largest minerals that have ever been found and where they have been found. Just kind of some fun, interesting facts. And as you click through these, you can kind of read through what each of them is and where they have been found. Some of them are very, very large. This video here is going to talk to you about a large cave that is made of salt. They actually carved into it. It's pretty cool. So that's all I have for the actual notes portion of it. I just wanted to kind of explain some of those things to you. You can go back and watch the videos or reread through them if you need to. And if you have any questions, please let me know. There is a link to a fill in the blank notes on Google Classroom, or you can just write the notes out in your notebook, whatever you prefer.